Okay, here's what I want you to try. I want you to go to page 472. All right, and I want you to try problem, let's go number 21. All right, now I want you to go through the entire problem and read it first and ask yourself, are the assumptions being met? Are we talking about independent samples? Do we know what about our standard deviation? Since standard deviation seems to be the key here, we got to pay attention to what we have as far as if I know the population, if I know the parameter, then I get to play on z, and that's easy because that's just the normal curve. But if I don't, then I'm going to have to use that silly t-chart and play around with that one. So play around, enjoy, and I'll meet you back here after you've tried it out, okay, with the solution. All right, let's roll. Now, you probably got an answer that you're like, oh my God, I must have made an error on, but it's actually very compelling and it's interesting to talk about what's going on. So first things first, I like to organize my thoughts with problems like this. I let mu1 equal my high interest FICO people, okay? So these are the people that are paying a high interest. My mu2 are my low interest FICO people, so these are the scores that came out of that. So my null hypothesis is that they're equal, that they're FICO scores. Think of these FICOs, I meant FICO scores. So these are the FICO scores of the people, so they're either equal or that the high interest people have lower FICO scores than the low interest people. Okay, alpha equals 0.01, and my degrees of freedom, remember, you take the smaller of the samples and you subtract 1 from them, and in this case we ended up with 39. All right, because they both have 40 in the sample. Then I just wrote down what I got. So my FICO scores, my low interest people, I took the average of their FICO scores, and I ended up, FICO is just it's a credit rating agency, okay? It's based on all kinds of things. We'll talk about it more in class. There were 40 of them. The average was 594.8 with a standard deviation of 12.2. Excuse me, in the low interest, the people who paid lower interest on their mortgage, there were 40 of them. They had an average of 785.6 and a standard deviation of 16.3. I chose to use the critical values. When I'm dealing with T's, why do I have to use T's? Well, that should be obvious. It's because I don't know the population standard deviation. Otherwise, this would be a lot easier because I just play ball on the standard normal curve. So my alpha is 0.01. Ooh, that's a little different. But all that I do is I'm going to draw my curve. I'm going to use critical values. I go to the chart, the T chart in the back of the book, and I go to degrees of freedom, which is 39. I go to the area in one tail. It's clearly a left tail, remember. My inequality always points in the direction of the tail. And I got a critical value of negative 2.426. There should be a negative in there somewhere. Sorry, it's a little hard to see. What the? There, negative 2.426. Then all of a sudden, all hell breaks loose. But you may already be able to tell something's crazy here. I've got a mean of 594.8 and 785. That's huge. That's almost 200 points. And my standard deviations are very small relative to those, right? So there's no way that somebody who's scoring in this group, in this high interest group, I mean, if I get 3 standard deviations away, it's only 36 points, and I'm almost 200 points away from the low interest. So when you plug it in, that plays out numerically. You end up 60 standard deviations away from the mean for their difference. Now, what does that really say? Let's wrap our brains around that, because if all you do is follow the numbers, it's kind of like following the end of your nose. You won't really know what's going on. In other words, if these two were equal, the number of standard deviations away from the mean that we would be 60 standard deviations away. Think about what the p-value would be 60 standard deviations away. I mean, the p-value would be less than 0, right? They'd actually, well, there's no such thing, but clearly it'd be so close to 0 you wouldn't be able to tell the difference. All right, negative 59.27 ends up, well, not here, but off the screen, around the corner, and around the world with respect to this curve. So clearly we're going to reject the null hypothesis, which we pretty much knew before. There's huge evidence that people with lower FICO scores pay higher interest rates. Now, I can't do a confidence interval around this because I've got a not equal to here. Now, you may say, Ripley, in your lectures, in your online lectures, you're not doing a whole lot of confidence intervals. It's because we're going to do a bunch of them in class. By the time you're done, you'll have more than enough practice with confidence intervals. Okay, so this was a sort of an exaggerated problem to help sort of I don't know, make some discussions about what happens when you get a hugely different number like this, or excuse me, you get a huge t-value like this. Well, it just cries that there's a huge difference between these two values, which makes sense, right? For those of you that don't know anything about mortgages, the first thing that they do is they check your credit rating. It's the first thing, and they're like, oh, okay, well, your credit rating's in the 700, so here's going to be your interest rate. And if it's lower, then the interest rate goes up. All right, hope that was helpful. We'll see you tomorrow.